Okay, so on page 1 here, we're going to be factoring all these using difference of squares. All right, so the x squared minus 25, that's going to factor into two binomials like this. It's got to have an x and an x in order to get x squared, and it's got to have a 5 and a 5 to get 25. One of these is going to be plus, the other is going to be minus. So the reason that I can use difference of squares here is because x squared is a perfect square. X times x gives you that, the same number twice. And 5 times 5, that will give you 25. So both of these are perfect squares. That's one. And it also has to be subtraction. So like on number 10, I can't use difference of squares because it's addition. Number 10 is prime. It does not factor. All right. If we were looking at one like number 11. All right, so 64 is a perfect square. 81 is a perfect square. So it looks like we're going to be able to use difference of squares here. All right, 8x and 8x, those will multiply to give you this. And then 9 times 9 will give you the 81. 1 plus, 1 minus. There we go. Let's see what else is out here. Number 6, you can use difference of squares here. You would need to factor out a 2x first because they have a greatest common factor there. The 2x to the third would become an x squared, and the 18x would become a 9. So just kind of check yourself. If you were to multiply that back out, you would get this original. So that is the greatest common factor factored out. But then you would want to take this and break it down using difference of squares. Okay, let's see here. Number 4. Number 4, that would be 3 plus x and 3 minus x. They just kind of wrote them funny. Okay. Yeah, 16 looks kind of crazy. I'm going to do 21. So this is a perfect square because it's equal to xyz. xyz times itself will give you that. And then 36 is a perfect square because of 6 times 6. 1 plus, 1 minus. All right, you'll be able to do something similar to solve number 16 there. Okay. Man, 24 and 25, these are kind of odd looking. Number 24, let me look at that. So this is a perfect square because it's equal to 2z minus 3 times itself. So I'm going to put 2 of those there. And then x plus 7y, that's going to be the same thing, same idea. X plus 7y, x plus 7y. If I do that times itself, I'm literally going to get x plus 7y squared. Now, one of these is going to be plus, and I don't have to do anything special here. But on the one where it's minus, I actually have to minus this entire thing. So I need to put that part in parentheses, okay? So this would be the factored form, but I'm sure they want us to combine like terms, if there are any. Actually, there's not, because we have a z, an x, and a y. We're not going to have any common terms to combine on this one. All right. Normally, you'd have to distribute that negative and combine like terms, but on 24, you won't. If you were to do number 27 or number 34, you would have to do something like that. Yep. All right, so these are all difference of squares. 40 is another one that's prime because of the plus sign here. On 37 and 39, you're going to need to rearrange the terms. All right, this is equal to 25 minus x squared. All right, and then you're going to be able to factor that, no problem. All right, we'll call that good for this one. This has all been on difference of squares, pages 1, 2.